This is a quick review for Chapter 10 for geometry. And some of these parts we did not cover due to lack of time in this time of year. So these first two we don't have to worry about. Next set of problems. There's a circle here with some values given to you. And again, before you answer these questions, mark up as much as you know about the circle here. They're asking you to identify any major arcs, minor arcs, or semicircles. And also find the measure of each arc. Well, I have 50 and 70. As we know, the central angles are the same as the arc angles. So it's 50 out here, 50 there, 70 is central, 70 is an arc. Well, this line here is 180, going through this diameter, going through the center, 180. So we know this whole arc out here and this angle here alone are both 180. And again, 180 from C over to D on this side. Well, the 50 and the 70 add to 120. 180 minus 120 makes the angle in here 60, and the arc angle is 60. Now, as you label these, you can just abbreviate MAJ, MIN, or semi for each of these. If it has only two letters, it's going to be either a minor arc, less than 180, or a semicircle. So AD, there you go, 70 degrees, it's minor and 70. AB is minor, 60, just abbreviate, 60 degrees. CD, C to D is a full 180. And it's a semicircle. It's half a circle, so it's semi, it's 180. BDC has three letters, so it's going to be more than 180. Let's see, B to D to C. Well, the easy way to do this, of adding these three numbers up, I would just subtract this from 360. Full circle is 360, so that'd be 310. So that's major, 310. ACD, A to C to D. Again, I'd add up, instead of adding all three of these values up, I'll subtract 70 from 360. I get 290. So this is also a major and 290 degrees. BC's two letters, oh, right here, 50. And it's also minor. Okay, for this problem, anytime you have a tangent or two tangents that come from the same point, because the point could be here, above it, but anywhere around it, you draw two tangents to both sides of the circle. The two tangent lines themselves, the x plus 8 and this value, this expression, will be equal. That distance equals that distance. They're asking you just to find x. Sometimes they ask you to find x. Well, actually, they ask you to find the length. So I'll show you how to do both in this case. So for this one, again, this x plus 8 equals 5x minus 4. These two are equal. So x plus 8 equals 5x minus 4. I subtract x from both sides. 8 equals 4x minus 4. Add 4, I have 12 equals 4x. Divide x equals 3. That's all they asked you for, but if they ask you for the length, well, it'd be x plus 8. Well, x is 3. So AB equals 3 plus 8. AB equals 11. Well, guess what? This segment should be the same. You said they were equal up here. Well, I'll put 3 here. 3 times 5 is 15. 15 minus 4, yeah, 11. All right, bottom of the page. Two circles, bunch of lines going through them, around them, just touching them. And the idea is to label what the type of lines they are, segments they are. On the test, you'll be able to just do it through matching. But try to do this before you actually see if you can remember about these different things. F is here. That's a point of tangency. So point of, I'm going to abbreviate, just write tangent. By the way, there's also a point of tangency for G, see where that's at, and E, and even A. So there's actually 4 points of tangency on this drawing. They just ask about F. This is line FE. The line, it's got the arrow, so it goes on and on, FE. I'll look for that, and I can see it going through here. This is called a common tangent because it's touching two circles. See FE here, F and E. This is a common, I'm going to abbreviate tangent. Segment HG, it's a segment. Little guy here, it's a radius. I'll abbreviate that, rad. AC is also a radius. Segment DB, starts and ends here. Now, it starts and ends at the circle, it doesn't go past it because it's a segment. So that would be a chord. C, center, as well as H, those are centers. of the circle. Segment BE. BE goes across the circle through the center, so that is a diameter. Diameter. And last one, line DB. We had BD earlier up here as a chord. It started and stopped here because it's a segment. The arrows mean it keeps going on. That's when it goes through the circle like that, that's called a secant. So make sure you know the difference between a secant and a chord. They look similar. Secant continues on. Page 2. So you have a circle and they want you to draw these items on that circle. You have this on the test as well. Now the key here is you see there's a B here, there's a B there, and a B there. You can't have 3 B's on your drawing. You got to have 1 B, and all 3 of these must use that same B. All right, so we'll start with drawing a diameter of AB. Now if I draw the diameter, it's got to go through P. I can draw it, horizontal, vertical, angle. It doesn't really matter. Whatever you want to do. So here's my diameter, here's my A and B. Check. It's a segment, not a line. Starts and stops. Tangent CB. Well, here's B. Don't put another B over here someplace. So I'm just going to draw my tangent. Touches B. Draw it as a line with the arrows. Now it says CB, so there's no C on here, so you got to add your C someplace. It could be here, it could be on this side, far away, close. Doesn't matter. Whatever you want. Next one's a chord DB. Well, here's my B. I don't see a D anywhere, so put it anywhere you like. It could be here, on this side, or over here, far away or close. Doesn't matter. Just make sure you label properly. So I use that B 3 times for the tangent, diameter, and the chord. All right, draw a secant through A. Well, here's A. The secant must go through the circle. I can use another point on here. Actually, I like to use D here. I don't have to, but I'm going to. It's a line going through the circle. That's my secant through point A. Could have been just another point over here. I could have made another point Z or K, whatever. But I'll use D. It was already there. And lastly, so what is the name of the radius in the figure? Well, there's 2 here. I have PB or BP, PA or AP. Doesn't really matter. PA is fine. It's just one of those. Next, we have our tangent lines. How many common tangents the circles have, and then draw them. So you got to give me a number and how many, and draw them. Well, these cross over each other, so the common tangent go like this, and also down like this. Now, if you don't quite touch or you cross the line, the circle of the line, I'm okay with that. And you write 2. Okay, if you try to draw one in here, it's crossing the circle, so it won't be a tangent. Here, well, you can't really do anything. If you draw one here, you're going to cross the bigger circle, right? And anywhere you try to draw, you're going to cross the bigger circle, so it can't be a common tangent. And outside, you always miss, you miss the inner circle. So this has 0. There's none there. And the third one here, you have 2 here on the sides, and you're drawing arrows because they're lines. And there's 2 more. They cross in between. Again, doing the best that I can to touch the circle just a little bit. 1, 2, 3, 4. There's 2 other types. Where there's one, you have a circle inside of a circle, kind of looks like an olive. Right there would be a 1 tangent. And what else we have? Oh, the one where we have the 2 circles and they just kind of kiss each other a little bit, just touching a little bit. So you have 1, 2, and arrows, and 1 right down the center here. So we have 3. So those are the different types. Next one here says RT and PS are diameters of circle N. Hey, I don't see a picture. Well, you gotta draw one. So here's my circle. There's my N. These are diameters, RT and PS. Doesn't matter where you put them on here or which direction, just draw them. Here's my RT, PS, P to S. There it is. Okay, then it says arc TP is 47. So here's 47. This arc is 47 degrees. Your job now is to go label everything else you can find on here, and it's a lot. This is the arc angle, which is always the same as the central angle. Okay, vertical angle, so you have 47. Arc again, 47 here. All right, you got that straight line of 180. 47 from 180 is 133, I think. 133. 133 is vertical. 133 is an arc. There you go. You got 8 angles there now. Now you can answer the questions they've given you. Arc ST. S to T. 133. Arc PR, P to R, 133. Arc RTP, go in order, R, T, P. Can add up these three numbers or subtract that number from 360. So I'll subtract that from 360. So 360 minus 133, I get 227. Yeah, 27 degrees. And last one, STR, S, T to R. Again, I'm going to subtract the 47 from 360 instead of adding these three numbers up. So 360 degrees minus the 47 is 313 degrees for STR.